Given the graph for y equals 1 over f of x below, graph y equals f of x on the same grid. State the domain and range for y equals f of x. Here, the graph of the reciprocal function of y equals f of x is given. In order to graph the original y equals f of x, apply the same ideas as for graphing the reciprocal if given the original. For each point x, y on the reciprocal, the point x, 1 over y is on the original function of f of x. Points for which y equals 1 or y equals -1 are unchanged. These are the invariant points. Vertical asymptotes on the reciprocal function correspond to points where y equals 0 on the original function. Points for which the absolute value of y is greater than 1 will become absolute value of y less than 1, meaning between 0 and 1, or between -1 and 0. Similarly, points for which the absolute value of y is less than 1, again that means between 0 and 1, or between -1 and 0, will become y values that are greater than 1 or less than -1. Note, however, that the sign of the y value will not change when either taking the reciprocal or converting the reciprocal back to the original function. The horizontal asymptote of y equals 0 corresponds to the absolute value of y becoming infinitely large. This means that y either becomes infinitely large in the positive direction or infinitely small in the negative direction. First, let's look at the invariant points where y equals either 1 or -1. We have the point -8, -1, -4, 1, 3, 1, and the point 9, 1. We then look at the two vertical asymptotes. We have one vertical asymptote at x equals -6. This corresponds to an x-intercept of the original function at -6. We have another vertical asymptote at x equals 5. This corresponds to another x-intercept of the original function of x equals 5. We'll now look at a few additional points in order to make this graph more accurate. We have a point on the reciprocal graph at -2, 1/2. On the original function then, this corresponds to -2, 2. The point on the reciprocal graph at 2, 1/2 will correspond to the point 2, 2 on the original function. 4, 2 on the reciprocal function corresponds to 4, 1/2 on the original function. 6, 4 on the reciprocal corresponds to 6, 1/4 on the original function. 7, 2 on the reciprocal becomes 7, 1/2 on the original function. It is then necessary to connect these points. For any portions of the reciprocal graph that are curved, the original function will be slanted. In this case, all of the segments of the original function will be linear. For x values less than or equal to -2, it will be a positive straight line. Between x equals -2 and +2, the reciprocal function is a horizontal straight line, so the original function, f of x, will also be a horizontal straight line at a y value of 2. The remainder of the points will also be connected with straight lines. Between x equals 2 and x equals 3, we'll have a straight line with a slope of -1. Between x equals 3 and x equals 5, we'll have a slope of -1/2. And between x equals 5 and x equals 9, this time we'll have a line with a slope of +1/4. For the domain and range, we'll be looking at the possible x values and the possible y values. For the domain, note that x cannot be greater than 9. We therefore have a domain of x less than or equal to 9, and x is an element of the set of real numbers. For the range, the maximum y value is 2. The range is therefore y less than or equal to 2, and y is also an element of the set of real numbers.